Welcome you all. I am G. Karthik, Assistant Professor, IT Department. So working in Kongnadu College of Engineering and Technology. Today we are going to see about HDFS, Hadoop Distributed File System in Big Data Analytics. So before that, we're going to see what is called as a big data. So what is big data? Big data is a huge amount of data. We call it as a big data. So there is a collection of data in a huge size. So that is we call it as a big data. So the big data considers of a whole scale diversity, complexity, and then a new type of analytics we are made in that big data. So this is called as a unit of memory. So likewise, there is a several kind of so byte is there, byte, kilobyte, megabyte, gigabyte, terabyte, and then so up to that yottabyte. So this type of memory right now available. So these are the sources for big data. So there is a different type of mobile sensors is there, social media, and then video surveillance. So these are all the areas so which is stored. So in a centralized storage. So in that centralized storage, we are doing the analytics with that different type of data. So this is we call it as a big data. So now we are going to see what is called as a HDFS. So this is called as a HDFS. The HDFS stands for Hadoop Distributed File System. So what is called as a HDFS? So HDFS means so we are distributing the data together, and that along with that distribution we are doing some process. So doing some process means, for example, we having the 100 GB of data. That 100 GB of data to be shared with the multiple nodes. Suppose I'm having 10 different type of nodes means I'm sharing the data to different type of 10 nodes. So working together, and the finally I am so receiving it as a whole. That is we called it as a so distribution of data. So in this HDFS, we having the name node. So what is called as a name node? So this name node only gathers so all the data nodes informations. Here the data nodes consist of the sub nodes which is available with that centralized node. Single name node runs in a cluster associated with one or more data nodes. The name nodes only collecting all those informations of the data node, and then all those information means it having the metadata about the data nodes. That is we call it as a name node. The name node effectively coordinates the interaction with the distributed data nodes. So coordinates means, so for example, so 10 different 10 different type of nodes available means we should share the data of data nodes to that name node. So out of the data node, any one of the data node got failure means immediately the remaining data nodes shares that corresponding failure data nodes to the remaining node, 9 nodes. So that is we call it as a fault tolerance, which is available in this HDFS. The name node maintains the metadata about that each file. So I already told the metadata means, so whatever the data we are stored in that data node, so that all information are have in that name node. So that metadata includes the enumeration of the managed files, and then properties of the files, and then file system. So mapping of blocks. So mapping of blocks means we already know how the data will stored in that data nodes. Always the data are stored only in a block by block. So each and every block information will be known by this name node. So this is the architecture of this HDFS. So here we are having the rack 1 and then rack 2. So in this rack 1 and then rack 2, we are having the group of nodes. So each and every block having the certain informations. So different type of sectors is there. So we are sharing the data nodes information to the data node via client. The data node will share the information of the metadata to this name node. The name node having the metadata about this all data nodes. Here I'm having rack 1 and then rack 2 data nodes. So both this rack 1, rack 2 data nodes information are available in this name node. For example, if any other server or client will request to gather some information in this data node, means immediately, first of all, it will contact with this name node. This name node having the all information about this data nodes. So immediately it will retrieve, so where the data exactly available. So with the help of this metadata, it can easily retrieve information in this rack 1 and then rack 2. The data node itself does not manage any information about the logical HDFS. We already know. So the data node itself does not manage any information. Does not manage any information means in this architecture, this data node, for example, or 5 GB of 5 GB of information available means it does not have all information about this 5 GB of data. So all 5 GB of information are available in this name node only. For example, so this block consider as a 2 GB, this block consider as a 3 GB, this block consider as a 1 GB. Like that, the data are available means the whole rack 1 data nodes information are metadata are stored in this name node. So that is what, so does not manage any information about the logical HDFS. So it treats each data block as a separate file and shares the critical information with the data node. So whatever information we are stored in that data block, the data block share those critical information to this name node, because always the any other server want to access information from the data node means, first of all, it will immediately contact with this name node. With the help of that name node, we can retrieve information easily in that data node. Here, once the file is created, so the data is written into file, actually so cached in a temporary file. Always, so we already seen the memory informations. So always we should have the cache memory, because the cache memory is that the history of informations they can store in that cache memory. Always the server or client immediately will contact with the name node. In that name node, we are having the so cache information. Cache information means what are all the informations. So previously we are searched. So with the help of that information, they can retrieve the data easily. So when the amount of data in the temporary file is enough to fill a block in a HDFS. Always, so we can store informations in a data block. So once the information is, once the data is got filled in that corresponding block, means immediately, so it will convert into the permanent memory. So before that, so once the data block is utilizing, and the time always it will be in a temporary memory, because that corresponding data block are utilizing. So always, so the data block in a process means always that will be only in a temporary memory. So once the data block got filled, after that will be, it will converted into the permanent data node. We can provide the fault tolerance. So fault tolerance is that we're having 10 nodes. Out of the 10 nodes, so any one of the data node got failure means immediately the corresponding failure data node workload to be shared with the remaining data nodes. So that is we call it as a fault tolerance. So that corresponding data failure data node information also shared with the remaining 9 nodes. So that is we call it as a fault tolerance. So and then fault tolerance through the replication distribution of data, and then fault tolerance through the replication, whatever information we are required to the failure node. So we can retrieve the information easily, because that corresponding workload to be shared with the remaining remaining 9 nodes. So that is we call as a robustness. So monitoring. So what is called as a key task for failure management. So this is we call it as a monitoring always. So the name node having the have contact with that data node frequently. So always that is we call as a heartbeat communication. Each and every frequent of time, the name node will update the information about that name node. So that is we call it as a heartbeat communication. Suppose if the data node heartbeat is not here, so the data node heartbeat not here means so data node does not provide any information to that node node means that data node considered as a failure. So that is we call it as a heartbeat communication. And then rebalancing. So rebalance is that, so the corresponding block is got failure means immediately the corresponding block information to be migrated to the other data nodes. At the time only that corresponding data node information to be shared with that corresponding name node. And then managing integrity. So managing integrity is that, so it provides a digital signature for accessing the data. So any one of the client want to access with that data block means, so we need to provide authentication. So with the help of that, so our data will be in a very security. And then metadata replication. So metadata replication is that so the metadata files are also subject to failure, and then HDFS can be configured to maintain replicas on the corresponding metadata files. So to protect against the corruptions. So provides we can provide good communication with the data node. At the time only we can so provides effective communication with the name node. So within that, so HDFS concept is over. So thank you all.